why don't we talk about why do I need coroutines? And by coroutines, I mean generators with .send. Let me be a little bit clear about the vocabulary, and those of you who have joined us for previous sessions on generators or async I/O may have seen me use this vocabulary. This is what I call a function, or maybe a subroutine. This is what I call a generator. This is what I call a coroutine. This is what I call a coroutine with a capital C, or an asynchronous function. And this is what I call an asynchronous generator. Now, if you look closer, you might say, well, hold on a second. What's the difference between these two? One you call the coroutine and one you call a generator. Is it just the name because it starts with G you call it generator because it starts with C? No. If you look at the generator API, it's not just the ability to do a next on this, to do an underscore next and then go to the next element. For a generator, you can also send data back into it. You can throw exceptions back into it. This is how, if an exception is raised within the context manager block, this is how it can make its way back into the generator if you use the generator formulation for this. You can even forcefully close the generator instance. Let me show you an example for where this might come up. Let's say you wanted to write a very simple generator that looped over a value. And so here, I'll show you this working. Loop over the value 10 over and over and over and over again. And you might say, that doesn't seem that useful. Well, in isolation, it's maybe not that useful, but it is a useful building block for other things. And in fact, this already exists. itertools.repeat is exactly what we've written here. Let's say, as part of this, you want to change the value as you go. You want to increment the value. So you want to start at 10 and go 10, 11, 12, 13, 14, 15, and so forth and so on. You might say, again, maybe not that useful, but it actually is kind of useful as a small building block to build bigger things. And this already exists. This is itertools.count. Well, count basically starts at a starting point and increments by 1. What if this operation here to change the value you're looping over is arbitrarily complex? You could think that this could be a little bit tricky for us to write. We might have to either pass a function in here and then call this function here, or if it required some external data, it just might get clumsier and clumsier. And the itertools module doesn't have the ability to, take some value and then repeatedly apply some operation on this to get you to the next value. It might be something that's useful in the itertools module, but doesn't exist. You can write this pretty simply yourself. Another way you could approach this problem is you could take that generator and you could understand that that yield is actually an expression which can return a value. And the value that it returns is a value that was sent into the generator. The .send basically means give me the next value, but also at the same time send some input in. If a function is something that takes input at one point, gives output at one point, and runs eagerly from input to output, you can't interleave anything. And a generator is something that takes input and gives partial output, and you can interleave behaviors. A coroutine is something that takes input and then gives you a partial output, then takes a little bit more input, then gives you a partial output, then takes a little bit more input, then takes a partial output. It's something which can take partial inputs and partial outputs. And here's a very standard formulation. And so here, I can loop over 10 3 times. Then I can update my looper. Now it's going to loop over 200, and a loop over 200 3 times. Then I can update my looper, and now it's going to loop over 3,000 and loop over 3,000 3 times. And so instead of taking input and giving output, or taking input and giving partial output, I can take input and give partial output and then take more input, give partial output and take more partial input, give output. And obviously the pattern breaks at the very end here. We can't take input here because, at some point we have to stop. At some point there's going to be a last output that we give. This gives us the coroutine. Coroutine is basically, with the lowercase c at least, is basically a generator where you can send data back in. And it does lead to some things which are a little bit perplexing for us, like this: can't send a non-none value to a just started generator error message. I can recite this with my eyes closed because it shows up all the time, namely that as a consequence of the way in which coroutines were added to Python, it is the case that you have to first do a next before you ever do a send. Now, why does this matter? Well, it turns out that what makes generators so interesting is actually largely due to what coroutines give us. Namely, coroutines give us the ability to transform functions into very slim stateful entities, or another way to put this is, coroutines give us the ability to linearize implicit data flow and control flow. In other words, let's say we have some entities, a couple of name tuples here, and we want to perform some operation on the min and max. And we can perform this operation with the key function. We don't control this API. This API takes a function. We can't change it. Min and max were written for us in the built-ins, and we're not going to say, oh yeah, add another keyword argument to min or max unless we're willing to get on Python ideas and argue our case. Now, here we're going to minimize and maximize this data set over one of the fields, over the C field or the B field. But what if it's the case that we wanted to sort this data, and we wanted to sort this data using something that was stateful? For example, we wanted to sort this data with a counter so that the first time we see each C value, that sorts to the beginning, and then each subsequent time we see that C value, it kind of pushes those to the end. So if we've seen the same C value 5 times, that goes at the end. If we see it for the first time, it shows up at the beginning. And if there's a tie, we use the actual C value in order to tie break. And so here, if you look at my sorting with this new predicate that I've written here that relies on this global variable, you can see the first time I see these C values, they get sorted to the beginning, but anytime I see them repeat, they get pushed towards the end. And the underlying C value actually determines the ordering. If there is a tie, you can see I saw this C value once, and this C value once already, and this one was larger than that one. Well, I might not want to write this with some global state. Because if I wrote this with a global state, if I had multiple units of computation in my program, then they would interact in ways that I don't really have an ability to easily debug. And so I might want to encapsulate that state in some fashion. What I could do is I could write a coroutine. And I could tell that coroutine, take a partial input, which is the next X value, yield some output, which is what the predicate would yield, the key upon which to perform the sorting, update some internal state that is stored as local variables, and to avoid that can't send a non-none value to a just started generator problem, I'll pump this. What I'll do is, when I create this function, I'll first instantiate it. I'll run a dummy next to go past this first next, and then what I'll return is I'll return the .send function. So it looks like it's a function, but it's actually the send method of a coroutine. And when I do that, I can implement my stateful predicate, but it looks like it's a function. Coroutines give the ability to take something that may need to be a function in order to fit a particular API and make it a function that can remember its state, because that's all a generator really is. It's just a function that can be resumed. And a coroutine is just a generator where you can send more data back into it. Now, you might look at this and say, well, why did I bother to do that? I could have just written a class, right? And the class could have created the counter as some encapsulated state, and I could have put a call here to comport with the API. And the call site looks exactly the same as before. Well, note, there's some data flow here. I'm creating the counter here, and I'm using it here. And there's some sequencing. The init must happen before the call. In a very simple example like this, no big deal. That's easy. We're going to be able to manage that, no problem. But as the code becomes more complex, like we have an F0, an F1, and an F2, and as the structuring for what happens after what the sequencing becomes harder or becomes larger, or introduces modality. Maybe F could go to F1 or F2. Maybe it's not just in a row. Maybe there's some branching here. And if it's the case that there's some data moving back and forth, like in each one of these, we set some state that might be used in the other, can you look at this code and tell me what the correct ordering of these functions is? You cannot. It is very difficult to see. Here, we rely on more state, which is only created here. So this has to run before this. And here, we rely on other state, which isn't created until here. So this has to run after this. And I guess this relies on state, which was set up in the init. So the only correct ordering of these methods is H, then G, then F. And this happens all the time in our actual objects. We connect to a database. Well, we need the database connection in order to do an operation on the database. We connect to the database and we configure the database. Well, we need the configuration to be set up in order to do the execution. We execute something against the database, and that gives us a cursor. And we ask the cursor for rows. Well, we need to do the query before we can get the results for the query. Implicit data flow and control flow is all over the place in all of our objects, and it can be very hard to see. And I'm sure you've all run into this problem. You ran a method on an object, it blew up in your face, you asked a colleague or a coworker, and they said, oh, no, you got to call this thing beforehand. And you're just like, how are you supposed to know that? Does it say it in the documentation? Do you have to read through every single line of code? Is that something that if it changes and an ordering dependency is added, I can controllably discover before it's too late? You cannot. Fundamentally, classes obscure data flow and control flow. Whereas, if we were to implement this as a coroutine, it is now linearized. This happens before this because this is lexically before this in the source text. This is on line 3 and this is on line 4. this happens before this because this is before this in the source text. The data flow is just the regular data flow that we see in functions. More state gets used down here, other state gets used here. And instead of, in the case of a Python class, where you often have one method of that class setting state into the class and then getting used at some unknown exit point, a coroutine can encode all of that complexity, but it forces all of the movement of data to be just the standard movement of data that you see in all of the code that you write, in all of the regular functions that you write every single day. And instead of the control flow being obscured, wait, what comes first, what comes next, where's the branching? You can actually see the branching because it's just a regular old branching that you have. If it's the case that there was some modality here where there was a choice of whether you do this or you do this. That might be some mode that's deeply hidden within a method in a class. Here, it's just an if-else. If one of these things is done repeatedly, it's just a loop. This is the power of coroutines. You can take a state machine that has been encoded in a class where you cannot see the data flow or the control flow, and you can encode it in a way that you can use it just as effectively in something that looks like a function, and you can read top to bottom, just like a function. That's the power of the coroutine.